Welcome to the archive, Jill Tarter. How you doing today?
I'm doing well. It's a pretty day out here today.
Nice, nice. And where are you at?
Berkeley, California.
All right. So good weather for most of the year.
Yeah,
Uh,
well, we've had a lot of rain, which we need,
yeah,
but today it's beautiful.
yeah. So you were one of the two founders of the SETI or SETI Institute.
Hmm.
So could you start with telling us just is that a robot
Sorry.
in the background?
Yeah, that's a dryer, actually.
Dryer, home office.
Yeah.
Um, Could you start with introducing what SETI is?
SETI or the SETI Institute?
SETI Institute.
Okay, well, the SETI Institute is a 501c3 nonprofit that I co-founded with Tom Pearson back in 1984 in order to save NASA money. Since there were no civil servant slots for people working on SETI at NASA, we had to hire all of our talent at soft from soft money faculty at local universities. So Berkeley and Stanford and San Francisco State. And at the time, in the mid 80s, there were just enormous indirect costs, sometimes 100%. And we had very limited funds and we wanted to spend them most efficiently. So we hired Tom Pearson, John Billingham hired Tom Pearson to take a look at various business models, how we could stretch those funds. And Tom said, well, look, if you form a nonprofit and instead of getting contracting with the local universities for the talent that you need, just have them become employees of the nonprofit. And then you can set an indirect cost rate that more realistically represents the cost of doing business this way. And that's what we did. I wrote the incorporation documents and Tom took them up to Sacramento, and we landed back then on an indirect cost rate of 20%, which is a huge savings over 100%. So it worked really well. And it worked so well that, fortunately, with the broad charter that I wrote, people who were not specifically interested in finding intelligent life or technosignatures, but were interested in the question of life beyond Earth, microbial rather than mathematicians, they began to say, oh, wait, I could do this with my grant. And so they came on board. And today we have over 100 PhD scientists working at the SETI Institute with this business model. And they're working on all kinds of different sciences related to origin of life, evolution of life, exoplanets. And it's really a great team of folks here. So it was a good idea. Tom had a great idea, and it's been working, and it's still working. Our overhead rate has gone up to slightly less than 40% now after all these years, but it's still lower than the competition, if you wish. So we're doing well with it.
Nice, nice. And so you and Tom were also former NASA employees.
Um, I was actually never a NASA employee. I was a NASA grantee through a proposal that I wrote from UC Berkeley, where where I was a research astronomer after I got my PhD. So yes, I got funds from NASA, but I was never actually a NASA civil servant employee.
Okay, NASA civil servant employee. All right.
Yeah,
Um,
that's a distinction. I mean,
yeah.
probably lost on most of your audience, but it is a distinction.
Okay. So in case those people that are watching who don't know what the civil servant employee entails.
Well, I mean, it's you go to work at a NASA facility and NASA pays your salary, and your lab equipment and all of that kind of thing. It's just NASA is your employer. And I actually don't know what the origin of the term civil servant is, but if you work for NASA, that's what you are, a civil servant. And that there are various ranks, and the federal government sets salary ranges for the various ranks of civil servants. So
All right.
best I can do.
All right. Well, that's good with me. I've learned a lot just from that. As I'm curious also a little bit about what kind of person Tom was, who Tom Pearson was.
Tom was fantastic. He Scientists often, because they're interested in the research that they're doing, often work far longer than 40 hours in a week. And when one of Tom's employees needed extra help to get a grant in on time, to do a cost analysis, to help with hiring, Tom was always there. It didn't matter how long we worked; he was willing to work right alongside us, and he had a good vision of how this institute could grow, and he had an even temperament so that he could help us travel across the funding roller coaster that we were on for decades. And he would say, okay, that one didn't work, but let's not give up. Let's go at it this way. And so he was just really, he played Santa Claus every year at our Christmas party. And that was kind of the guy he was. And he also joined us at local wineries for wine tasting activities. And we would exchange really silly presents at these things. And Tom's were always incredibly clever. And he was just a really nice guy to work with and very smart.
Yeah. Wow. All right. That funny enough, that is actually what I was expecting for an answer. um so like the best of what I'm able to research might not always be the most accurate, but Tom was the guy who founded SETI. Or started it.
He and I co-founded it, right? I wrote the charter and the terms of the specifics that the institute was going to be, and then Tom became the first CEO of the nonprofit that we created.
All right. And what got what was that inspiration? What made you both so interested in creating this?
Well, again, as I said, we were trying to save NASA money, or more correctly, we were trying to use the money that NASA made available and spread it farther so that we could build more instrumentation and do more observations.
Mm-hmm.
So it was simply a business model I would never have thought of. But in fact, when you put a grant into NASA, you have to include a certain percentage of the funding for cover indirect costs that NASA might spend, or you might spend, in order to do this research. And I didn't realize that it was possible to negotiate that indirect cost. And so we were just going along with what we were assigned when we first started working with NASA, just chomping at the bit, because we knew that we really didn't need to have that much money in indirect costs, because we were very lean and the way we were doing things just didn't cost that much, or we paced them to take place within the funding that we had available. So Tom came from grants administration at San Francisco State University, and he had a much broader picture of how you can fund scientific research. And it's not only one size fits all, but there are some clever workarounds or opportunities that you can create. And that's what Tom helped us do. And then, as I said, he was always there if we needed him. He wasn't some, CEO who went off and played golf every day. He was right there in the trenches with us, and just a really good, level-headed guy. And he passed away from cancer at far too young an age.
Yeah, that was unfortunate. And sounds like a role model for CEOs everywhere as well.
Yeah, yeah. At least my type of CEO. People who work at the SETI Institute really love working here, and it's the culture that Tom helped establish that is really, what can I do to help you? And so people are happy with that. They stay around for a long time. As long as they can keep getting money, they stay with us.
Nice, nice. So from what you've told me, my understanding is that NASA has always been interested in finding some form of not necessarily intelligent, but also microbial life beyond Earth
Yeah, since the 70s.
since the 70s. Okay. Um, is it possible to share why they were interested?
Well, NASA has a division that's biological sciences, right? And they were interested in the origin of life on this planet, the evolution of life, and how intimately connected life and the planetary environment are, each modifying and influencing the other. So then when John Billingham, who was a medical doctor by training, when he took over the life sciences division at NASA Ames, John was very bold, and he was personally interested in the question of, okay, microbes, we're trying to figure out whether there are any beyond Earth, but what about mathematicians? And so he took what was a somewhat well established field within NASA, the biological sciences division, and then found a way to broaden it to include the question of intelligent life beyond Earth. And, one of the things that we had problems with at the beginning was this concerns with UFOs, right? And establishing ourselves as something that is a legitimate scientific exploration, as opposed to the sensational and pseudoscientific work and reports about unidentified flying objects. So we really did take a lot of time to develop our legitimacy and stand apart from those other fields. So.
Mhm. Now, something I am curious about quickly is that within the last couple of years, what has become public, and there's now actually an office within the government researching UFOs and become very public about. Has that altered anything for SETI at all or NASA?
Well, as I said, after we got going and established our legitimacy as a scientific endeavor and exploration, then the UFO kind of connection or people's confusion died down for a long time. But now with this new office for discovering or understanding unidentified aerial phenomena, there's again this, well, isn't that what you guys at SETI are doing? And no, that's not what we're doing. So we're conjoined in the public's mind somewhat again. And I think that that office is quite legitimate, and that there are things that we see um, with our eyes or our instruments that we don't yet understand. Uh, there was the thing that I like is the best example is when high flying airplanes would see these anvil shaped thunderclouds and see something going on above them, right? And wondering whether that was somebody's technology, whether those were UFOs. And it took a long time until we had orbital sensors with fast enough reaction speeds, fast enough camera speeds, that we could understand that there are things called sprites and elves, which are just lightning strikes going up rather than down to the ground, but leaving the top of these anvil thunderclouds and going upwards. So we don't know everything.
Yeah.
But there's just so much yet to be discovered, I think. And if there's a legitimate question, I think that we should, in fact, try and find a way to answer that question. And astronomy has a fantastic history here. So we have, over the past few hundred years, gone to funding agencies and said, we want to build this new telescope or this new instrument to fly on spacecraft. And these new things will answer questions X, Y, and Z. Okay. And when we've gotten the funding and we've built it, they in general have answered the questions X, Y, and Z. But in fact, some great majority of the time, the most incredible and important thing that this new facility does is uncover something that we never expected at all, because we were now looking at the universe in a different new way. And there are many things out there to be discovered.
All right. That's great to hear.
Yeah, so astronomers are pretty big on serendipity. Start
Yeah.
looking at the universe in a new way, and oh my gosh, what's that?
Yeah. That is it's so neat to hear that. When SETI started in the 70s, what was that first initial like, did you guys have an office? Did they build something for you? Were you like a little closet office in NASA's headquarters?
Not at NASA headquarters, but at NASA Ames, which was really the driver for the early SETI work. And yes, there was an office with one administrative assistant, and John Billingham, who was head of the life sciences division, was in and out of that office and scheming things. And after a while, we had not just an office, but a trailer for multiple people. And that trailer actually sat beside the crematorium for animal specimens that the biologists were disposing of. So it, there was a time where people in academics would say, I'm going to wait till I get tenure and then I can work on SETI, right? Because now I'm stable and they can't fire me and I can work on what I want. I just have to find the funding to do that. So, but now I think two things have changed in the past couple of decades. One is exoplanets and the other is extremophiles. So the very first meeting that John Billingham organized at NASA Ames to talk about this question of life beyond Earth, and in particular, intelligent life, we said to ourselves, well, damn, life as we know it seems to be a planetary phenomenon. Are there any other planets out there beyond our solar system? Because we absolutely did not know. And so David Black was asked to start a working group on how we might answer the question about the existence of exoplanets. And he got together a bunch of people who had been thinking about different ways of doing it. And this whole exoplanet scientific field started as an offshoot of questions that we were asking in SETI. And in particular, Bill Barucki from NASA Ames, who was the project scientist for the Kepler spacecraft, which found thousands of planets. And, you know, was decades after we'd had that first workshop. It takes a while to get this stuff done. But Bill Barucki was at that first workshop, and he got really excited about some of the techniques to indirectly, because we don't image them, we indirectly detect the existence of planets because of their gravitational interaction with the star that they're orbiting. And so Bill worked for years, and I think he put in a proposal for the Kepler mission. I think it was 7 times before it was finally accepted. And I know that he had to go to Antarctica and to other dark sites and build prototypes at NASA Ames. And so there would be a black sheet with holes punched in it, and there'd be a light source behind it. And you try out various detection techniques. And so Bill really had an enormous amount of perseverance. And of course, now we know that there are more planets out there than stars. So statistically speaking, every star has at least one planet orbiting it. That's a huge improvement in our knowledge base compared to what we were starting with in the 70s. And the other thing is that we have begun to find biology and life in environments on this planet that I was taught as a student would be absolutely uninhabitable, could not support life of any kind. Well, it just meant our imaginations weren't as fruitful as Mother Nature's. And so now we know about all of this potentially habitable real estate, which isn't just the environment that you and I enjoy, but organisms can make a living at hugely high temperatures and pressures and very acidic or very alkaline environments, frozen in ice, all kinds of extremophiles, extreme by your and my sense of what we're comfortable with. And now that's just opened up the idea that there might be a lot more habitable real estate than we ever imagined. It doesn't have to be a rocky planet in orbit around a G-type star. Right? There are other environments where life could, in fact, flourish. We might not recognize it. We might stumble on it serendipitously, but we at least know enough to keep our eyes and our minds open to the possibilities of life as we don't yet know it.
Wow. It's pretty cool. Cool stuff.
Yeah, it is cool. It is cool.
And you get to work on this every day.
Yeah. Well, our scientists are astrobiologists too. Yeah. I mean, was it last year? There was a big to-do in the press about the statement at the end of one paper that what had been detected might be phosphine molecules in the clouds of Venus. All right, well, phosphine's a fairly simple molecule, but the thing that made it exciting was the fact that on Earth, as we produce phosphine, every mechanism for doing so involves biology, right, to produce this molecule. So if we're seeing it in the clouds of Venus, were we seeing evidence that life was floating in those clouds, life of some kind? I think Carl Sagan used to call them bobbers, floaters, and sinkers, organisms that could make a living out of the chemical potential difference between the top and bottom of a cloud around Venus. And so people got really excited about this claim of phosphine, and so lots of other people worked on it and tried to confirm that detection. And in the end, since it was from the beginning only a single line detection, we finally decided that it was a misidentification, and that feature was more than likely to have been caused by sulfur dioxide rather than phosphine, and therefore biology wasn't necessary. But we'll keep looking. There are folks at Cornell. Aaron Freund is her name. She is working with a number of different groups to try and figure out all possible small molecules that could be made or might exist naturally, and what their spectroscopic and optical properties would be like. So now we've created this huge encyclopedia, and when something gets discovered, perhaps in the atmosphere of a nearby exoplanet, when some spectral feature shows up, we can compare it against this vast database to see if we can identify what that molecule might be. And how likely is it to have any role that eventually leads to biology and life?
All right. Nice. Very, very nice. Yeah, like a lot of new information, but
Yeah, and you know what's great for me personally is that these two new fields of scientific research, looking for exoplanets and trying to understand extremophiles, because they're new disciplines, they aren't all stuffed up at the top with, excuse me, old white males, right? Who prevent upward mobility of younger and more diverse scientific populations. But because these haven't been around for very long and they're exciting, lots and lots of people have piled on, young scientists. And in particular, some of the best and the brightest are young women. And I think that's terrific. I love to see these women becoming leaders and organizers and champions for these new scientific pursuits.
And beforehand, you starting at the time of which you started, you were a minority there in NASA or SETI or the scientific research field.
Oh yeah. Well, when I started at Cornell as an undergraduate to get my engineering physics degree, I was one woman out of 300 of the entering class that year. And it's certainly gotten better since then. We see more and more women. There are now more PhDs in the sciences granted to women each year than men. And that's primarily because of the rise of the biological sciences. But nevertheless, we're seeing a lot more women. And then it's just really good because sometimes different genders, different ethnicities, different backgrounds think about a problem in totally different ways. And we don't want to miss out on a solution to a question because we have excluded some population of scientists.
Okay. Interesting.
Yeah, in fact, sort of at the end of my career, I've become a bit of more of a proselytizer. So I like to talk to audiences of all ages about this concept of life and intelligence beyond Earth. Because if people listen to me for 40 minutes or an hour, it forces them to see themselves from a larger perspective, maybe a cosmic perspective. And I think that these interactions, talking to groups, is like holding up a mirror right? And saying, see, everyone that you see in that mirror, you think they're different. They look different, perhaps, but they're not. They're all the same when compared to the possibility of an independent origin and evolution of life beyond Earth. And so that cosmic perspective is really useful for us today on this planet, because we have all these challenges, many of which we've created ourselves, but challenges that aren't going to be solved by any one nation state or any individual. We're going to have to use all of the skills and all of the diverse ways of attacking a challenge. And so we're going to have to cooperate across countries to come up with solutions. And so I like the fact that if you talk about life beyond Earth, intelligence beyond Earth, what you're doing is trivializing the differences among humans, some of which we're willing to go to war over, kill over, right? This cosmic perspective that compared to something else out there, we are all earthlings, we're all the same, I think is going to be very necessary as we go forward, trying to find a way to have a long future for life on this planet. We're going to have to see ourselves as earthlings. We're going to have to adopt that cosmic perspective and learn how to cooperate globally.
All right. And after doing this for 50 years, Jill, has it changed how you see yourself or life?
Well, I don't think when I started, I would ever have thought about myself trying to proselytize and sell this idea of being an earthling as a meme, right? That was a bit too, I don't know, intelligentsia for me. I was really more nuts and bolts, and how do I get the computer to do this, and how do I recognize a pattern in voltage as a function of time that might indicate a technology. That was all head down and solving those kinds of problems, which is great fun. And it's still going on today. In fact, we're now in an era where we're bringing in neural networks and machine learning to help us do this job better. But it's only been over time that I've realized that not only do we have to educate the world and fight for funding to do this research, but that the nature of the research can in fact bring people together. I mean, I have old YouTube clips that I sometimes show. Actually, I showed it a couple of weeks ago at the UN of Ronald Reagan or who else? Hillary Clinton saying, you know what? If we knew that there was an alien army coming to Earth to threaten us, we would instantly cooperate and collaborate to protect ourselves, right? And all the differences that we fight over would just drop away. Well, I don't think you need the actual threat. I think just the concept of the cosmic perspective, the concept of being an earthling, will allow us to collaborate and find solutions to these challenges that threaten our potential long future. So I never thought about myself preaching, but that seems to be what I'm doing these days.
Preaching for science. Yeah.
Yeah.
Was science like something, just getting into that field, is that something discriminated against? Was it looked at differently, like how it's looked at today? Like nowadays, I can even see um, artists and people who are not science suddenly very fascinated with it.
Yeah, well, we've gone from STEM to STEAM and kept the artists in there. And at the SETI Institute, we've now for well over a decade, had an artist in residence program, because we found that when you're thinking about something that you don't understand, don't know what it might be, is really beyond our current knowledge, that working with an artist who sees things in different lights, who can, in fact, draw your attention to perhaps a different facet of something that you've been working on but just hadn't gotten there. The artist has really been a useful tool for us. And it's I worked with one of our early artists in residence who would ask me every day for a month to just send him an email with a sentence or two about what I was thinking about that day. And at the end of the month, he took the standard calendar, right? Days of the week, days of the month. And in each one of those calendar squares, he made an image of representing what I had been thinking about and telling him about that day. And I have it on my wall. It's a very, very nice piece of artwork. But you'd be surprised that Ernie and Bert, the Muppets, are in some of those squares. And that's because there are detectors for in the ice of the Antarctic looking for high energy cosmic rays. And there was a day where they had two events that were larger than anything that they had seen before, really startlingly large. And they began to think about what was different, what made that happen. And just as an offhanded way of denoting those two events, they called one Ernie and one Bert. And so Ernie and Bert got into my scientific thinking for that particular day. Yeah, and so I see this on the calendar and I chuckle and see other things that I try and remember. Well, what was I thinking about? What did I tell George about that day? And yeah, it can be very useful. This artist in residence concept, I think, can be very useful for scientific organizations. And CERN, for example, the accelerator in Europe, has been doing this for even longer than we have at the SETI Institute. And they really find it rewarding to help their scientists to envision things that we can't yet envision, that we don't know about.
Yeah. And would you or Tom 50 years ago had pictured it would have gone to where it is today?
No, I'm not very good at predicting the future. I would have been hopeful that we would still be doing this work. I guess I would have been incredibly hopeful that we might have found an answer to the "are we alone" question. And having found number 2, we're going on to look for 3, 4, 5, infinity other worlds supporting life. So yeah, I would have been hopeful that we were doing that work or had found at least one answer. But I don't think I would have predicted how we've actually gone about it. For example, when we started, we knew that we were looking for particular patterns of voltage over time. This one pattern, narrowband frequency, continuous wave carriers, signals, something that nature can't produce, but something that our technology does all the time. And so we started building instrumentation that was particularly efficient at finding that kind of signal. Back then, I wouldn't have thought that we would branch off or incorporate signal detection algorithms that look not just for continuous narrowband signals that change frequency slowly, but that we would include optical signals that weren't compressed in frequency, but were compressed in time. And we're now doing optical SETI and trying to look at all the sky all the time at all frequencies for, up until very recently, particular patterns that we thought likely to require technology rather than just life or astrophysics. But now we're actually able, because of machine learning, which certainly was around when we started in the form of science fiction, but wasn't implemented, wasn't available early on. Now we're beginning to use machine learning to say, okay, don't just tell me whether this pattern or that pattern are in my data, but tell me whether the data contains any kind of information and isn't just noise. So we can broaden the search in a very different way than we've been able to do before. And I'm sure there's going to be a lot more things that come up. We didn't understand when we started doing this that if we were using a telescope, particularly a radio telescope, we thought that we had to have control of that telescope. We had to be able to point it where we wanted to look, where we thought there might be intelligent civilizations. But now we've learned, thanks in part to John Billingham, the biologist, about doing commensal observing. We've now understood that you can get to a telescope and look at the voltage that's coming out of the receivers of that telescope as a function of time. And you can actually split that signal into two different paths. And you can do it in a noise-free way and amplify up the output so you don't really pay a voltage penalty. And one of the paths is the traditional one. And whoever's using the telescope is going to be using those data for their own purposes. But the other path can go into a back end that's for SETI, a whole bunch of computers and algorithms that are looking for this idea of information embedded in the signal stream. So we don't always have to build a telescope and control it ourselves. We can commensally observe. Sometimes it's called piggyback observing, but commensal is the correct biological term. We can commensally observe on many different telescopes around the world, which are being used to do lots of different scientific explorations. It doesn't matter that we're not pointing to where we think we should point, because we really don't know the right direction to point the telescope. What we want to be doing is observing as much of the sky for as much of the time over as wide a frequency or wavelength regime as we can. And we can do that by making use of data that somebody else is collecting for their own purposes. So commensal observing is not something I would have ever thought of when we got started.
Thank you for all these wonderful answers, Jill. My last question for you is going to be, do you have any message for future generations?
So if there's something that you're interested in, go ahead and put in the effort to study that and get better at doing that than anybody else around. And then you'll have a skill set. And you can take that skill set and apply it to all kinds of different problems that come up. You can try and find answers to all sorts of different questions, given the fact that you are skilled at manipulating data. And I think that if you do that, you're going to continue to be able to ask the questions that you're interested in and try and find answers. And then it's not like a job, right? It's like puzzle solving. It's it's a game. And it's really intriguing and sometimes very hard, but you're not bored. And you're working on things that you yourself are intrinsically interested in.
All right. Thank you, Jill.